and talk about domain and range when we have composite functions. So last lesson, like I said, I skipped one part on this page. So by the property of inverse, okay, skip that part. So what I want you to think now is, like for not reciprocal, inverse functions, if you learned methods last year already, you should know this property, right? Have we learned that before? Yeah. So if you put inverse function into the original one, you should get x. But if you put inverse into the original into the inverse, you should get x as well. But we need to have suitable domain. Okay, so you need to think about the domain. There's domain restrictions. So the domain can only be the domain for the inside. And so there's a restriction for domain. So now I want to talk about something like there's two, well, not only sign, like cos inverse, tan inverse is the same. I just use sign to represent it. Since he doesn't want to come in. Okay, so for those two expressions, x can be anything. Okay, x can be, well, something suitable for the domain. Which one is always true? There's one always true and one not always true. Which one is always true? Is that because I didn't give a reaction when you said first one, so you change it to the second one? Yeah, second one is always true. Let's think about why is always true. Okay, think about that. What you can put into sine inverse? You can put a ratio into sine inverse, right? So for example, half, negative a half, a quarter, you put a ratio in. And what do you get from sine inverse of that ratio? You get an angle, right? You get an angle out. So sine inverse a half, you get the angle pi 6 out. And then you put this angle again into the sine. You should get the same ratio out. Okay, so you get the same ratio out. So that value should be the ratio. So you put the ratio in, you get the ratio out. That's no problem. So for example, you put ratio half in. You get an angle which gives you a ratio of a half. And you further put this angle into sine again. You get the ratio, same ratio as before. So this one was no problem. And the ratio must be in between -1 to 1. We all know that. But let's have a think about the first one. Give you an example which is not true. Like sine inverse sine 3 pi over 4. Will this equals to 3 pi over 4? Why not? What's the range for sine inverse? What's the range for sine inverse? Negative power 2 to power 2. It's not going to have 3 pi over 4. So it's not going to equals to 3 pi over 4, but it will equals to pi over 4. Okay, so I'll explain how you get the pi over 4. You need to adjust that into the suitable domain. Like the range of sine inverse can only be negative power 2 to power 2. If you put the angle, originally put the angle which is out of the domain, you're not going to get that out. You're not going to get that out. So the second one is always true. First one is not always true. It will be true when it's in the suitable domain. Like say x is in between negative power 2 to power 2. Then you can directly get the angle out. Okay, let's think about what's going on. Okay, quite a lot to go through. Let's have a think. Okay, sine what can give you negative a half? If you think about that, it needs to be in those two domains. Like your range is negative power 2 to power 2. So sine what can give you negative a half? Minus power 6. Okay. You never get quadrant. You either get 4 and 1 or 1 and 2. You won't get quadrant 3. Science, like what we take for sine, we take negative power 2 to power 2 for sine. And we take 0 to pi for cos. And we take minus power 2 to power 2 for tan. It's either quadrant 4 or quadrant 1 for sine. Never go quadrant 3. Okay. Yeah. Cos what give you root 2 over 2? Power 4. Okay, these ones are straightforward. If you think about cos, you only consider those two quadrants. So positive only exists in the first quadrant. So that's power 4. Well, even though in the fourth quadrant cos is positive as well, but we do not think about the range in the fourth quadrant. So we only think about first quadrant, second quadrant for cos. Okay. Okay, example 10. Let's have a think. I want to talk about how we can quickly get this question done. So this is the case not always true. So minus 13 power 4 definitely out of the domain. What's minus 13 power 4? What I can plus? I can plus 4 pi, right? 16 power 4. That's 3 power 4. So first of all, I can convert the angle into that. But that's still not in the domain. They're still not in the domain. But let's sketch it. What's the eligible domain for tan inverse? That's those two quadrants. Okay, so tan can only get angle in that two quadrants. Okay, the thing is, 3 power 4 is here. This is the sine quadrant. Tan is positive or negative in this quadrant? Negative. So if you want to get a negative thing in for tan, you should convert to this quadrant here. Okay, so if you have this angle here, is the cos quadrant, it will be negative for tan as well. So you will mapping this angle into that quadrant. So the angle is actually minus power 4. So we can actually convert this one into minus power 4. Then is within the domain. We have minus power 4 for this question. Yep. Yep. The ratio, not the angle. Do you talk about the angle here? The angle. You can take plus 2 pi, 4 pi. You can. For tan, you can. Tan pure is pi. You can. Yeah, you can add that. But that's only for tan. Okay, for the next one, sine. Let's have think about sine. Boys, it's just too loud. I can't teach. Okay, if you think about sine, sine is good for this quadrant, positive in this quadrant, and negative in this quadrant. 3 power over 4 is here. So this is the sine quadrant, so it's positive. So if you want to put this angle into a same positive quadrant, it must be this one. So they should have the same reference angle here, pi on 4. Okay, this one got a reference angle pi on 4. Also, it's in the positive quadrant. So I want angle in the positive quadrant with the same reference angle. It must be this one in the quadrant 1. So this angle can be changed into pi on 4. It's the same because sine 3 power 4 and sine power 4 will give you the same value. Okay, same positive, both positive, both same reference angle. So I should have the same ratio out. So this one can be converted into pi on 4. Then it's in the domain. So the answer can directly get pi on 4 out. Okay, so the answer is directly pi on 4. Sine inverse sine x equals to x if x is in the eligible domain. So from negative pi on 2 to pi on 2. Okay, so that's this one. That's with the same sine inverse and sine, tan inverse and tan. But if you have cos and sine combined, we can't do this quick method. So what we need to do, we need to just evaluate. Okay, what's sine minus pi on 3 equals to? Negative root 3 on 2. And cosine, we think about this quadrant and this quadrant. Okay, cosine inverse, we think 0 to pi. So what will give you negative? Okay, 5 pi on 6. Cosine pi on 6 give you root 3 over 2, and it's the negative. It's in the negative, like second quadrant, so it's 5 pi over 6. Okay, this one. Any idea what we should do for this one? Draw the graph. So sine inverse is the angle, right? Sine inverse negative 5 over 7, that's angle theta. Let's say that's a theta. So sine inverse negative 5 over 7 equals to theta. Sine theta equals to negative 5 over 7. Which quadrant this theta must be? Which quadrant? 4. Negative in the fourth quadrant. So if I draw an angle here, that's the angle theta. And I want sine theta. Sine theta is minus 5 over 7. So sine is opposite over hypotenuse. That's here. And for this one, 49 minus 25 equals to 24. Root 24 is 2 root 6. So this length is 2 root 6. Now the question changed to what's cosine theta? What's cosine theta? 2 root 6 on 7. Okay, that's how we do it. So inside is the angle. So we first assume that's the angle theta. So what we can say about this angle? No, we don't have cos inverse. We only have sine inverse here. So we consider the reciprocal one. We are not reciprocal. We consider the inverse. So which one is the inverse? Sine is the inverse. So what's the range for sine? It's negative pound to pound 2. And doesn't matter with the cosine. Yep. Okay, if we go to the next page, what we should do to this one? How many triangles? Draw 2 triangles. So if we think about this one is the alpha, this one is the beta. 2 angles, okay? The question changed into sine alpha minus beta. What's sine alpha minus beta? Sine cos minus cos and sine. Okay, combine the formula. Now let's think about what's alpha and beta. Alpha equals to cosine inverse a third. Cos alpha equals to a third. Tan negative 5 over 12 equals to beta. Then tan beta equals to 5 over 12. Okay, that's the ratio I can write. And they're both in the first quadrant. Or positive. Positive is always in the first quadrant. Okay, beta is 5 over 12. That must be 13. And that's 1 over 3. 9 minus 1 is 8. 2 root 2. Sorry, wait, cos. That's 1, that's 2 root 2. Wrong way. Cos. Wait, what I just did. No, positive only in the first quadrant. So cos inverse in first or second quadrant, right? So positive is in the first quadrant. Tan is second and first and fourth, first quadrant for positive. Okay. Okay, this triangle is correct. Okay. Cosine alpha is 1 on 3 and tangent beta is 5 on 12. That's correct. Okay. Let's look at the graph and then just write a value. What's sine alpha? Sine alpha is 2 root 2 over 3. And cos beta? 12 on 13. Cos alpha? 1 on 3 and sine beta? 5 on 13. So that's a 24 root 2 minus 5 over 39. Denominator is the same, it's 39. And the top of the first one is 24 root 2, second one is 5. This is a very important question. Okay, this is a very important question. You will have similar things on part 1 exam. Any questions? No? We move on to next page. Where's the end of this period? What time? 15? 15? Thank you. Okay, I'll just quickly talk about this question here. This is a VCAT question from 2006, like long time ago. So if you have, okay, just ask you something irrelevant, like from maybe year 10. For quadratic, positive quadratic, if I want to say y is greater than 1, what do you need to do? The quadratic, all the y value greater than 1. So I said, doesn't matter what is x, all the y value greater than 1. What you can say? What's the lowest point for quadratic? Turning point. Not really, right? For 0, turning point. Okay. If I say all the value, y value is greater than 1, what you can say about this turning point? If I say all the y value is greater than 1, what you can say about this turning point? Turning point is above 1, right? Turning point is above 1. And then you can make sure all the y value is greater than 1. Now let's think about this question, tan inverse. What's the lowest value for tan inverse? The asymptote is kind of the lowest value. You can't really reach the value, but like everything will be above that asymptote, right? So let's think about this question. Tan inverse x minus 1 plus a tan pound 8, where a is a real constant. Find the minimum value of a for which y greater than 0 for all x. And giving you tangent pound 8 is this value. So you know the value. Tangent pound 8 is a number. Okay, so it's a number times a. What's the graph should look like? If I say the lowest value needs to be above 0, where my asymptotes should be? The lowest possible on 0 or above 0? On 0. And then the graph will be above 0. So if I draw my xy axis like this graph, like the okay, in this case, you can make sure all your graph is above 0, right? All your y value is above 0. Like the lowest, the bottom asymptotes needs to be just on the x-axis. Then you can make sure, or if it's above x-axis, that's fine. Okay, if it's above the x-axis, that's fine. But that's the extreme case. Okay, if it's on x-axis, I can make sure all the graph is above 0. So in this question, what is the two asymptotes? No, like in terms of a and pound 10 and pound 8. So how do we find asymptotes? What's the original asymptotes? Negative pound 2 and pound 2. So in this case, what has been done? Yeah, it has been moved up by this one. Yeah, like I can expand it later. So it has been shifted up. Like that is a constant, that's a number. So it has been shifted up or down, like by that unit. It has to move up and down. All right. This asymptotes. Okay, if I was to write an inequality, what's the sign must be compared to 0? Greater or equal to? Okay, if this asymptote is just on 0, that's fine. Or if it's above 0, I can still make sure all the values is greater than 0. Yeah, so if asymptote is pound 2, your y value is greater than pound 2, so it's still bigger than 0, still satisfy what I require. So if asymptote is greater or equals to 0, then the whole graph will be greater than 0. Okay, so that's the idea for this one. It's very similar idea to the when we talk about the quadratic. If you can make sure the turning point above 0, then all the y value is greater than 0. So you're looking at the minimum value. So what's the minimum value we have is on this asymptotes. So if the asymptotes is just on 0, then the whole graph will be above 0. Any questions? Well, I can solve for A in this case. No. Exam 1, see? Well, you can, oh, okay. A root 2 Yeah, that's fine. You can rationalize, you can times root 2 plus 1, but you don't really need to rationalize. Like, you won't lose mark if you don't rationalize. Yeah, like a minimum will be just pi to root 2 minus 1. But all the possible a will be that. All right. The next question is same as what we just did, but a little bit complex compared to the previous one. You can try for that later. And also talk about one last thing for this exercise. Okay, see. So this is one of the, guys, just be quiet for 5 more minutes. I have 5 minutes. I must go through that. So that's an example on textbook. And last, a lot of questions, a lot of students ask me like, this not make sense for them, like why they don't understand the restrictions. So in this question, what we assume is an assumption. Like, we assume, because we start to talk about cosine inverse, sine inverse, and tan inverse. In this case, we need to restrict the domain for cos, tan, and sine as well. So in this question, what our assumption is, where is a sine x? We assume the x needs to be belongs to negative pi 2 to pi 2. Okay, so we only take this part of the graph. If it's a cos, like, we assume x is in between 0 to pi. And if it's a tan, we assume x only belongs to negative pi 2 to pi 2. Again, otherwise you can't do this question. So this one is because we want to find the inverse of sine, cos, and tan. Therefore, we only restrict it. We only give this part of the graph. So that's the idea for this question. So we combine sine inverse and cos inverse, tan inverse into sine, cos, and tan. Then we make the assumption first. My sine, cos, and tan, the domain is there. Okay, we assume this domain, not R. Domain is not R anymore, so we assume this domain here. Okay, now we can start to talk about this question. How we can make a composite function? Like, what's the request for composite function? Inner functions, what needs to be what of the outer function? Yeah, the range of the inside must be a subset of domain of outside, right? So let's have a think. First of all, let's think about sine x. What's the range for sine x? Range for sine. Negative 1 to 1. Is that a domain for cos inverse? Is that a domain for cos inverse? Yes. So this one works. Okay, I don't need to restrict the domain. So what I need to do is 2x must be in between that, because that's the domain for sine. So we assume that's the domain for sine. Domain for sine is no longer R. In this question, we assume the domain for sine is in between negative pi 2 to pi 2. So x is just in between negative pi 4 to pi 4. And what's the range? Range for cos inverse, range for cos inverse, 0 to pi. Okay, that's how we do this. Okay, the thing is, first of all, we think what we can start into sine. So sine is to satisfy this domain, negative pi 2 to pi 2. So we solve this inequality. We solve this inequality. We get x in between this range, this domain. Okay, so that's the x. And what's the range from sine? Range from sine is negative 1 to 1. If I further sum negative 1 to 1 into cos, what do we get? We get 0 to pi. So the range, what we get out from the cosine inverse is 0 to pi. Okay, that's the range. I just want to show this one, B. Okay, I'll show B. B is a little bit different. So first of all, what's the domain for x in this case? What I can put in sine inverse? Negative 1 to 1. Okay. What I can get out from sine inverse? Quick, everyone. Okay, negative pi 2 to pi 2. What I can get from 2 sine inverse? Negative pi to pi. Okay, this is my new domain to put into tangent. Okay, to put into tangent. So if I put negative pi to pi into tangent, is that satisfy the domain? No, so that's too big. Okay, so the range is too big. I need to restrict it. So if you think about sine inverse, If you think about 2 sine inverse, this will be 1 comma pi, and this will be minus 1 comma negative pi. So that's too much. I don't want all these values. So just give me 1 more minute. That's minus pound 2. That's pound 2. Okay, I need to restrict it into this range. Okay, in order to put into tangent. Okay, restrict it into this range. So 2 sine inverse x equals to pound 2. Sine inverse x equals to pound 4. What's x must be? Sine pound 4 root 2 over 2. Okay, so this point is root 2 over 2. Symmetrical property, that's minus root 2 over 2. Can I take pound 2 in tan? Well, answer is no. I can't take pound 2 in tan. So it's open circle here and open circle here. So all of this doesn't work. X must belongs to bracket minus root 2 over 2, 2 root 2 over 2. And then the y value belongs to r. Yeah, tangent looks like this. Range is r. Okay, so that's the hard part. Okay, have a think about that. If you have problem, we can do another example for tomorrow. We can show another one. Try to finish C and D by yourself. Okay, try C and D.